I'm Stuart Brunt. In this video, I'm going to briefly explain how to find the upper range value and the lower range value for a differential pressure transmitter. So let's get started. In this situation up here, we have a tank. It's filled with water. We know that because the specific gravity is 1, and it's 12 feet high. And we have a wet leg over here that has a specific gravity of 1.8, so we know it's more dense than water. Alright, here's our pressure transmitter, here's our high side, here's our low side. So, let's find the upper range value and the lower range value. What we're going to do is we're going to use this formula over here. And this formula over here says that our differential pressure is equal to our pressure high minus our pressure low, which would mean our pressure high minus our pressure low. So, for the lower range value, in this situation, we have 0 inches H2O for our pressure high side. 0 inches because our pressure transmitter is actually even with the base of this tank, which would be at 0 feet of water. Okay, so we're going to have 0 inches H2O for our pressure high minus our pressure low side, which is going to be this hydrostatic pressure here. And in order to do that, we're going to use 12 feet of water, times 12 inches times 1.8 because of the specific gravity of this wet leg. Now we have the hydrostatic pressure for our pressure low side. And once we use this formula, we're going to find the differential pressure, and that's going to give us our lower range value, which is going to be negative 259.2 inches H2O. So for our upper range value, what we're going to do is we're going to look at this high side over here. We're going to look at the entire range because this is our upper range value. Low range, upper range value. And we're going to say, 12 feet times 12 inches of water times our 1 as the specific gravity because we're looking at this side now. And we're going to use that number and we're going to subtract it from our lower range value, or from our pressure low is what I mean to say. And our pressure low, which is what we just calculated over here, that is 259.2, and when we subtract them we get 115.2, negative 115.2 inches H2O. So it's kind of ironic. Differential pressure transmitter, upper range value, lower range value, negative 259.2 and negative 115.2 inches H2O. But let's look at this next equation, and this is the last equation. So now we have a pressure transmitter, differential pressure transmitter, that's below our same tank over here, 12 feet high, water's in the tank, same fluid in our wet leg. But it's 6 feet below, so what are we going to do differently? Well, a few things. But first of all, we're going to use the same formula. We're going to use this differential pressure equals pressure high minus pressure low. So our lower range value in this situation is actually not, the pressure high side is not going to be 0 because the pressure high side is not flush, is not equal to the base of the tank. It's not aligned with the base of the tank. The pressure high side on this side is actually 6 feet below the tank. So we got to find this hydrostatic pressure. So that's going to be 6 feet times 6 inches times our specific gravity. I meant 12 inches. 6 feet times 12 inches times our specific gravity. And that's going to give us 72 inches H2O. So now we have our pressure high. And our pressure low is actually going to be 18 feet because that's this entire pressure low side over here is what we're looking for. 12 feet and 6 feet, that's 18. So 18 feet times 12 inches times our density over here, our specific gravity is 1.8. So 18 times 12 times 1.8, that's our hydrostatic pressure. And pressure high minus pressure low, boom, negative 316.8 inches H2O. We're done with our lower range value. So now we got to use our upper range value. We're going to use this again. And this time, we know that we're going to use for our pressure high, we're going to look at this entire distance here, and we know that's going to be 18 feet times 12 inches times 1, which is going to give us a number that we're going to subtract our wet leg side, which isn't our lower range value like in the last situation. The lower range value was actually the same number that we took away. But in this situation, our lower range value was a different number than this actual distance here. And that actual distance was our pressure low. And we're going to use that same number over here. And we're going to subtract it. And we're going to get negative 172 inches H2O. So that's how you would get the lower range value and the upper range value for a pressure differential pressure transmitter that's mounted below the tank. Well, I hope this was useful. Just the main thing to know is it's useful to mark your high side and your low side. It's useful to know what you're looking for. I hope this was useful. And if you have any questions or comments, please leave them in the links below. Alright, thank you. Have a good one.